Welcome back to Mr. Reed Math, where we take the mystery of math and we make it past tense. Now there's a catchphrase for you. Okay, so we're going to go back to triangles and we're going to do a simple skill today. What we're going to do is we're just going to find the range of the length of a missing side. If you had two sides provided, such as 4 inches and 6 inches, the question is, what is the possible length that that side could be? And there's a whole range of them. So that's why we say we're going to find the range of the length of the missing side. So let's look at this. This first example has to do with the first rule that comes to finding that third side. And it says the length of the new side must be less than the sum of the other two. So I've got two examples right here. I've got one that's 4 inches and I've got one that's 6 inches. All right, let me get the piece of paper out of the way for just a second. So we take the 4-inch piece and the 6-inch piece and we put them right together. And when we add this length up, we come up with 10 inches. So if the rule is correct, then the length must be less than 10 inches. Well, let's put that to the test real quick. So here's a piece that's 11 inches long. Now, I don't know about you, but that's 3 sides, and gee, seems like maybe we ought to be able to make a triangle out of that. Well, let's see. So 11 inches, 6 inches, and 4 inches. And when I try to make a triangle, I can make 2 of the vertexes or vertices touch, but this third spot up here, it just never reaches far enough. Okay. Looks like the rule's pretty solid to me, because let's bring in this other piece. Now we've got 4 inches, we got 6 inches, and here's one that's 8 inches long. Clearly it's less than the sum of the other two. Well, if the rule's right, they should go right together, and look, they do. Okay, so rule number 1 works for me. Let's look at rule number 2. Rule number 2 says the length must be greater than the difference of the other two. All right, we know in math, difference means you subtract. So let's take one that's 4 inches and one that's 11 inches. Pull these out of the way. Now, the easy way to check the difference is to put them next to each other. All right, if we start at a length of 0 here, and we go to the right, stop at 4, well, now from here to the other end, that's the difference in length between those two pieces. Okay, so it says the length of the new side that we bring in must be greater than that difference. So let's bring in a piece that's 6 inches long. Now, I know that 11 minus 4 is 7, so if the rule's right, this isn't going to work. And you can see it's not greater than the difference. Well, let's make a triangle. If I pull that one down, and I pull that, yeah, I've got 2 vertices that work, and then this third one, they just never reach each other. Okay, so let's go back and let's choose a different length. So there's 11 inches, there's 4 inches, and now this piece is 8 inches long. You can see that its length is greater than the difference of the two. And when we try to make a triangle out of these, super easy, okay? No problem. So we have now proven our 2 rules. I'll put that there for just a second while I get the other sheet of paper. Last thing I'd like to do real quick is show you an example of how you work these problems out on paper. So there's a paper. Now, we have 2 lengths that are given, and then we've got to figure out this. Now, sometimes you'll see they'll put a question mark there. I like to put an X, okay? And when we come down to the next line, this is going to be the range. This is going to be the lowest value, and it's less than this one, which is going to be our X, and then X is less than this one, okay? So back to the rules. The length must be, so this must be less than the sum of the other two, okay? So what's the sum of 11 and 5? 16. So X must be less than 16. All right, and then rule number 2, the length must be greater than the difference of the other two. All right, well, what's the difference between 5 and 11? 6. Now, for our class, all of our problems, we're going to be dealing with whole numbers. We're not going to make you do decimals, although decimals could work. But to keep things simple, we're just going to say, what is the least value that that could be and meet the rule? Well, it could be a 7, right? It can't be a 6. 6 would be equal to, and it wouldn't make a triangle. The greatest value could be is a 15. If it were a 16, again, you wouldn't get a triangle out of it. Okay, that's how you find the range. Let's do this other one real quick, and we'll be done. All right, so I have 2 lengths given, 7 and 7. That's going to be my X, and that's where my X is going to go. Now, X has to be less than the sum of the 2 other lengths. So 7 plus 7 is 14. Okay, and it must be greater than the difference. Well, there is no difference between 7 and 7. That would be 0. Okay, so X, if we're just using whole numbers, x has to be at least 1, and it can't be more than 13. So from 1 to 13 would be the range of lengths. There we go. I hope that made sense, and I look forward to seeing you next time. Have a great day.